Hi everybody, my name is Ern Ling and I'm from the Singapore Civil Defence Force. I'm here at the University of Maryland to pursue a Master's in Fire Protection Engineering. And my project here is about the study of fire plumes. What exactly is a fire plume? I have a picture here showing a pool fire. So a fire plume is basically the flow of hot gases or smoke above the fire source. Like this, and my project is about studying this fire plume, like how fast it moves up the air and where is it going to reach. The purpose of doing this is to basically look at certain things like the velocity of the fire plume, so that we can know how fast the smoke from the fire is going to reach the ceiling, and from there we can then work out, for example, what kind of detector we want to install in the ceiling in order for it to be effective. Because if we know how fast the smoke is going to rise and hit the ceiling, then we can know how fast we want our detectors to respond. Okay guys, we talk about the study of fire plumes, right? So I hope you're not expecting me to show you a real fire, because I'm not going to use a real fire here, man. It's going to be very dangerous. I'm using a technique known as the salt water modeling technique to study the fire plume. Well, pretty cool, isn't it? It's using salt water. Yeah, you're right. It's this kind of salt that you might take every day in your food. So I'm using pretty much the flow of salt water in fresh water to study a fire plume. Now, how am I able to do this? It's because salt water has a density difference when we inject it into fresh water, and like the hot gases that is above the fire plume, hot gases has a smaller density compared to the ambient air, and so it's able to move up the fire source. Now right here, central to my experiment setup, I have a big tank, and it's a big tank of fresh water into which I would inject my salt water. You might want to take note of a few things. The water is actually analogous to the ambient air, and the salt water is analogous to the fire source. So as the salt water flows down, we are looking at a similarity between that and the flow of the hot gases up from a fire source. So in saltwater modeling, we are looking at it in an inverted way, right? So the floor would be right on top here, and the ceiling would be at the bottom. Now inside my tank, I also have a block. It's made of plastic, and it simulates a building. So I'm able to study the interaction of the fire plume or hot gases or smoke with the building. I have a blower on the left hand side over there. It takes in water from the pump and it pushes the water out to create a wind effect on the building as well as on the fire. So besides studying just a simple fire plume, I'm able to study a fire plume in a crosswind. Now right here, I have my salt water source. I have two tanks, one on top and one below. I'm pumping salt water from the bottom tank right up to the top tank, and from there it goes through a flow meter right here, and it gets injected into the freshwater tank. Now, how do I capture the speeds and the velocities of the saltwater plume? Now, I do this by using a laser right there. If I switch on the laser, you would be able to see flashes of it in the tank. Now when that laser shines into the tank, it will illuminate the seeding particles that I have inside the tank. And when it does that, the camera right here is able to capture the movement of the seeding particles as it flows through the water. So by tracking the movement of those particles, we are able to calculate the velocities of the saltwater plume. So I'm also using a computer to help me capture the images as well as to process it. Well, I can show you some of the colorful images that I'm able to get from this method known as PIV, or particle imaging velocimetry. Well, here I have an image, an instantaneous image of the saltwater plume. You can see that as it flows out of the injector here, which is like the fire source, it moves down and it gets turbulent, just like how the hot gases above a fire source would be in a turbulent flow. Now when I process the images, I'm able to get these velocity vectors. It looks colorful, and it is going to tell me at every single point in the plume what is the velocity there. And when I do an average over, say, a sequence of images, for example 1,000 images, I'm able to get a picture, an image that shows me the mean velocity. So from here we can see the plume spreading out as it goes from the top to the bottom. We can see how the plume speeds up as it comes out of the injector and how it starts to slow down as it moves down. So this is how we track the velocity at every point in the plume using the PIV method. That's about all that I have for you regarding my experiment. Before I came to the University of Maryland to take up this program, I am actually a firefighter back in my own country. So in my daily work, I deal a lot with things like putting out fires, doing fire investigation, looking at fire protection measures, preventive measures, and emergency plans. So the things that I learned here at the Fire Protection Engineering Department in UMD is going to help me a whole lot when I get back to Singapore. The knowledge that I gain here is going to help me in my work. It's going to give me a better understanding of the science behind fires, the knowledge behind maybe fire investigation, for example. So I would be able to better appreciate what I see on the ground. What else did I want to say? Oh, my experience. Oh, yeah. My experience here in UMD. Well, I haven't been here for a very long time, just for a year or so. Well, I find that studying here is very exciting to me. I'm able to apply a lot of things that I have learned even back at home here. I'm learning a lot of new things here. I get to work with interesting equipment like lasers, big tanks, big freshwater tanks with salt water in there. Things like the PIV method. These are all very state-of-the-art technologies that I get to touch and work on. So it has been a great experience for me here. So I hope you would be able to have this one day, and see you soon here.